Well, let's talk about a special op-amp circuit called the voltage follower. The voltage follower is often known as a unity gain buffer, and the reason is because the circuit will end up with a gain of exactly 1. If we take a non-inverting amplifier circuit that we've seen before, where we have a voltage in coming into the positive terminal of our op-amp, and connected via feedback through a resistor RF and connected to ground through a resistor RI, then we have shown that the gain for this particular circuit is equal to 1 plus the ratio of RF to RI. Now, if we were to either set RF equal to 0 or RI equal to infinite, we would end up with a gain of 1 for this particular circuit. There's no reason we can't do both. So if we set RF equal to 0, that's the equivalent of having a just a direct connection from V out, right? And if we set Vi equal to infinite, that's the same as disconnecting the circuit from ground. And we end up with I'll draw the power sources in here as well. We end up with a circuit that looks like that. Now, you may wonder, what is the point of having an op-amp with a gain of 1? Because all we're doing is moving voltage from one side of our diagram to the other side, which would be accomplished with, say, a wire. But the reason is that it allows us to basically buffer the downstream components, whatever the load downstream is, from the voltage supply. So no matter what happens to the load downstream of this particular buffer, it won't affect the voltage that's going into the buffer. Let me explain. Let's say that we have a 5-volt power supply, and we have some circuit, and we don't know what's in this, but we need 2.5 volts to go into this particular circuit. And we'll draw in a ground down here. Now, if we wanted to supply 2.5 volts to the circuit, the first thing we might think of is to simply use a voltage divider that we've seen in previous lectures. And that would be, for example, in this case, if we had a resistor, we had 2 resistors in series, and these resistors were exactly the same size, then, as you know, the voltage intermediate between these 2 resistors would be exactly 2.5 volts. But the problem is that when we connect our circuit to this 2.5 volt source, this circuit is drawing some amount of current. And if the circuit draws some amount of current, that means that there's more current flowing through the first resistor than there is flowing through the second resistor. And if that's the case, then the actual voltage of this intermediate point here won't be 2.5 volts anymore. Now, we could make R really small, and if we made R really small, then the current flowing through this part of the circuit is going to be much greater than the current flowing through this part of the circuit, and so the voltage won't change from 2.5 volts very much. But if we make these small and we have lots of current flowing through these resistors, that means we're going to waste an awful lot of power, because of course power is equal to the current times the voltage. Now, even worse, if the current draw from our particular circuit changes over time, we have no way of ensuring that we can adjust the resistances here to maintain a nice constant 2.5 voltage supply. So here's where the voltage follower comes into play. Let me erase a little bit here. So if we connect up our op-amp as a voltage follower, we connect the input to the positive terminal, we connect the output to our circuit, and we feed it back, that output, to the negative terminal, just as we did before. Add our power supplies. Now, because of the golden rule, the golden rules, if we supply a nice steady 2.5 volts to the input here, 2.5 volts to the input here, then the op amp will do whatever it needs to do in order to make these two, the inputs to these two terminals the same. And so it will adjust its output to be 2.5 volts regardless of how much current is drawn on through the circuit. And it does this by relying on the positive voltage supply or the negative voltage supply, by relying on those to supply whatever additional current, whatever additional power it needs in order to maintain that 2.5 volts. So now we can make the resistance of the resistors R, we can make it fairly large so that we have very little current flowing through our voltage divider, so very little wasted power, but a nice stable 2.5 volts to feed into our voltage follower and allows us to supply the circuit with a nice constant 2.5 volts.